Hello and welcome to the Daily Space. I'm your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put science in your brain. And to start things off, we're going to show you just how picturesque science can be. Mars Perseverance rover has released a color 360-degree panorama of its landing site. Like all good phone camera panoramas, things look pretty distorted in this rectangular view. But this does give us a hint of what's to come. The camera that took this image, Mastcam Z, can zoom, record video, and provide wide angle and panorama shots like this one. We'll have the link to the original in our show notes so that you can zoom in and out yourself and really appreciate the scope of the image.
As awesome as it is to squee at the Martian landscape as Perseverance does its best imitation of Ansel Adams, there is science to discuss, people. There is science. Researchers from the Southwest Research Institute have used 11 years of images from Mars Reconnaissance Orbiter to track seasonal activity on Martian sand dunes, tracking airborne dust plumes and the emergence of linear gullies. And they think they pieced together what is happening. In a new paper, in Geophysical Research Letters, Cynthia Dinwiddle and Timothy Titus explain that they often find chunks of dry ice at the base of the gullies, and they believe that spring heating can cause some carbon dioxide to vent and to also break off a chunk of dry ice that will slide down the gully, stirring up the dust plumes and carving the gully as it goes. According to Dinwiddle, for 2 decades, planetary scientists have had many ideas about how and when very long, narrow gullies formed on frost-affected sand dunes on Mars. Initially, scientists thought linear dune gullies were remnants of an ancient time when the climate on Mars supported liquid water on its surface. Then, repeat imaging showed that changes were happening now, when Mars is cold and arid. Several hypotheses have since been proposed, usually involving either carbon dioxide ice or water ice. In this paper, we offer compelling new evidence that venting carbon dioxide gas dislodges carbon dioxide ice blocks that carve and modify linear dune gullies. And there you have it. Mars may not have flowing water, but it does have sliding ice.
Believe it or not, Mars isn't the only world with spacecraft. Venus not only has the orbiting Akatsuki mission, but it also just got a flyby from the Parker Solar Probe. This NASA mission uses the gravitational pull of Venus to adjust its orbit as it dives in and out of the sun's corona. Back in July, Parker captured this stunning image of the night side of Venus. Yes, the night side. It turns out the camera they used was more sensitive to infrared light than anyone knew, and they were able to see the glow of warm clouds and the dark sweep of the cool Aphrodite Terra highland region. This was completely unexpected and quite by accident. This team seems to have found a window through the Venusian atmosphere while just trying to get a picture of its glowing terminator, which they got. That glow along the edge is night glow. Oh, and that streak? It's probably just a cosmic ray hitting the camera in a particularly artistic way.
Not all science gets to be pretty, but that doesn't mean the results still can't be awesome. As you may have heard last year, NASA released a set of moon rocks collected by Apollo astronauts for new analysis. Today, we have new results from these old rocks. In a paper published in Science Advances, Alberto Saul and Eric Howry discussed the molecules found trapped in lunar volcanic glasses from the Apollo 15 and 17 missions. According to the release, this new study looked at 67 individual volcanic glass samples and their melt inclusions, tiny blobs of molten lava trapped within crystals inside the glass. Melt inclusions capture the lava before sulfur and other volatile elements are released as gas during eruption. They found a variety of different ratios of sulfur isotopes, which implies different lava flows came from different reservoirs within the moon. By understanding the history of the lava flows, we can now start to understand the history of the moon's interior, too. There are still more samples to analyze, and we hope that there will be more samples returned by future missions. This research is just beginning, and we look forward to future results.
From planets and moons, we now jump wildly to the beginning of the universe. One of the more confusing things we've had to try and figure out in recent years is how massive galaxies with supermassive black holes were able to rapidly form at close to the beginning of time. The universe was pretty hot back then, and hot material tends to be fast moving and not particularly likely to collapse down into stuff like galaxies and stars. A couple of decades ago, it was theorized that cosmic filaments, cold channels through the chaos, could pour material into forming galaxies. While the theory made sense, no theory is to be believed until we have observational evidence. And now we have that evidence. In a new paper in the Astrophysical Journal with lead author Hai Fu, researchers present observational evidence from the Atacama Large Millimeter Array of cold filaments channeling material into a massive galaxy. According to Fu, based on our observations, such streams can fill up the reservoir in about 1 billion years, which is far shorter than the amount of time that was available to the galaxy at the epoch that we were observing. These observations were only possible because there are two even more distant quasars shining light through the forming galaxy. Basically, we got lucky. From our perspective, 3 massive galaxies formed in the same patch of sky within the first 2.5 billion years of the universe. And the 2 more distant galaxies allow us to see cold filaments in the nearer system. As Fu says, so I feel extremely fortunate that nature provided us this opportunity to detect this major artery leading to the heart of a phenomenal galaxy during its adolescence. When we come back, I'll be discussing Supernova 1987A, and later in the show, Beth will be explaining new evidence, further confirming just what killed the dinosaurs. Stay tuned. In theory, a supernova should go off in a galaxy like ours about every 100 years. Frustratingly, we haven't seen one in a lot longer than 100 years. This could be because supernovae have been going off in hidden places, for instance, on the other side of the center of the galaxy or behind one of the dark molecular clouds where stars like to form. No matter what's going on, a nearby supernova hasn't been in our galaxy's cards. And the best we have is a supernova, 1987A, that went off in the nearby Large Magellanic Cloud. The Large Magellanic Cloud is actually a galaxy imitating a cloud as seen from the southern hemisphere. First appearing on February 24th, 1987. Astronomers have been able to track this system's evolution in glorious detail. And this year, one particularly looked for detail has started to let itself be seen. Sort of. Supernova 1987A is the result of a massive star running out of fuel in its core. When this happened, the core collapsed, in theory, into a neutron star, and the outer layers bounced away to form the nebula we see today. The thing is, for the past 34 years, no one has been able to see the neutron star in this system. To be fair, it's still a mass of gas and light and debris that we can't see through with our telescopes. It's expected that when we can clearly see that collapsed core, we'll find it's a rapidly spinning pulsar. For now, though, we can't see it directly. But using a suite of modern telescopes, a team has detected what appears to be the effects of a pulsar spinning in the middle of this mess. This is pretty extraordinary. That spinning neutron star should be about 10 miles across and have a mass several times the mass of the sun. We are literally looking for an object with about the diameter of Manhattan Island that is located 168,000 light years from Earth. Luckily, this small object can put on an amazing show. The show, unfortunately, is in colors of light our eyes just can't see. This team looked at Supernova 1987A in the X ray with Chandra and NuSTAR, and in longer wavelengths with the Atacama Large Millimeter Array. Their results, published in the Astrophysical Journal this week with lead author Fazio Bocino, show a mix of high energy X rays, brightening radio emissions, and other behaviors consistent with a neutron star spinning in the center of the supernova remnant. According to co author Marco Maselli, astronomers have wondered if not enough time has passed for a pulsar to form, or even if Supernova 1987A created a black hole. Co author Marco Maselli goes on to explain this has been an ongoing mystery for a few decades, and we are very excited to bring new information to the table with this result. Alcatori Orlando adds, being able to watch a pulsar essentially since its birth, it's unprecedented. It might be a once-in-a-lifetime opportunity to study the development of a baby pulsar. The birth and evolution of pulsars is something that occurs on human timescales. Supernova 1987A is a millennial, and it has been watched as it matures by the boomer astronomers. By the time the Zoomers are running the astronomy community, that pulsar should be easier to detect, and over the next several generations, astronomers on Earth will be able to watch the pulsar emerge from behind the spreading debris and even slowly change in its rotation rate. I fully expect our technology to advance in unimaginable ways over these generations. But even though our current data may be seen as primitive, it's well-calibrated, accurate data. And this will be the first time we've been able to digitally measure a supernova, its central remnant, and how it all changes over time. The closest we have to this is a supernova that went off in 1604, the supernova that formed the Crab Nebula. It was described by the likes of Johannes Kepler and Johannes Coniac. That event was documented with drawings and written comparisons of its brightness to that of other stars. While this data is awesome, and the nearness of the system allows us to readily measure its continued expansion, this isn't the same. I'm still holding out hope for a visible light supernova in our galaxy that we can see with our eyeballs. But until that happens, we have Supernova 1987A. And today, 34 years and 1 day after we first spotted it, we can say hello to the pulsar spinning in its core. After the break, we'll be back with an update on the death of the dinosaurs.
We've talked before about how advances are made in science one step at a time, and with the work of a lot of different people. And sometimes advances are made by asking, but couldn't it be? And waiting to see if you are right or wrong. This means that someone is always checking out weird alternatives just to make sure the weird stuff isn't really. Such is the case with the object that ended the reign of the dinosaurs nearly 66 million years ago. What was it? We've been calling that 7-mile wide object an asteroid much of this time, but was it really? Could it have been a comet? That's the hypothesis proposed in a paper published last week in Scientific Reports with lead author Amir Siraj, an undergraduate at Harvard University. Siraj and his advisor used statistical analysis and gravitational simulations to calculate what fraction of long period comets, those that originate from the far distant Oort cloud, are shifted off their original orbits by Jupiter's gravitational field. This shift would make them swing into what we call a sun-grazing orbit, passing very close to the sun. Close enough, in fact, to experience a tidal disruption event that breaks the comet into lots of smaller pieces. And perhaps some of the larger pieces could come back around and hit Earth on their new trajectories. The new calculations increased the chances of these impacts by a factor of 10 from previous calculations and show that about 20% of these long period comets become sun grazers. This new rate of impact aligns with the 66 million year age of the Chicxulub crater, which is the impact crater of our dinosaur killer. Additionally, there is evidence that the object was a carbonaceous chondrite in composition, which is rare for a main belt asteroid, but possibly common for a comet. The paper also cites several other large impact craters here on Earth that matched with the expected impact rate of sun-grazing comets. More samples, particularly from those other craters and even comets themselves, are needed to confirm this hypothesis. In the meantime, the other thing science is good at doing is rejecting alternative claims on the basis of stronger evidence. In a paper released just yesterday in Science Advances, a team of scientists published the results of their analysis of nearly 3,000 feet of rock core from Chicxulub crater. They found conclusive evidence that the object that impacted Earth and wiped out the dinosaurs was an asteroid based on the chemical fingerprint of the dust within the crater. Per the press release, the telltale sign of asteroid dust is the element iridium, which is rare in Earth's crust but present at elevated levels in certain types of asteroids. An iridium spike in the geologic layer found all over the world is how the asteroid hypothesis was born. In the new study, researchers found a similar spike in a section of rock pulled from the crater. In the crater, the sediment layer deposited in the days to years after the strike is so thick that scientists were able to precisely date the dust to a mere 2 decades after impact. That layer of iridium dust is actually what kicked off this quest to understand what happened 66 million years ago. That layer is called the KT boundary, and it can be found all over the world. In the 1980s, scientists analyzed the layer and found the iridium, and then the evidence began to pile up, culminating in the discovery of the Chicxulub crater in the 1990s. Chicxulub is a 125-mile wide crater at the northern edge of the Yucatan Peninsula, and now we know definitively that its age matches the time of the disappearance of dinosaurs in the global fossil record. The team found that the concentrations of iridium were highest in a 5-centimeter section of a core pulled from the top of the crater's peak ring. This is where the rocks rebounded and then collapsed after the impact. You can search online for some amazing videos of simulations of the impact. Also, per the press release, in addition to iridium, the crater section showed elevated levels of other elements associated with asteroid material. The concentration and composition of these asteroid elements resembled measurements taken from the geologic layer at 52 sites around the world. So, to sum up, a 7-mile wide asteroid, not comet, hit the Earth 66 million years ago in what is now known as the Chicxulub crater. The dust from the vaporized asteroid and rocks in the crater ended up in the atmosphere, circled the planet, blocked the sun, brought about a nuclear winter, and wiped out the dinosaurs, along with 75% of the rest of the plant and animal life on the planet. And mammals became the dominant species. So, thank you, asteroid. We'll be right back with a look at the moon, which is taking over this week's stargazing prospects.
This week, we have a full moon. And I have to admit, this is one of the 4 full moons of the year that I like to pay attention to. This is one of the full moons that rises during twilight and is pretty easy for a beginning photographer to photograph. At 3:17 a.m. Eastern, 2:17 a.m. Central, the sun, the earth, and the moon will all occupy the same plane in the sky. I say plane instead of a line because the earth and the moon aren't lined up, and the moon will be outside Earth's shadow, shining brightly in the sun. Our eyes, and for the most part our cameras, will see the moon as full for all of tomorrow. Moonrise will be within a few minutes of sunset for mid-latitude locations in the US and Europe. This means that if you go out to a nice flat area, a plowed farm, or an expansive golf course, you will see the sun and moon setting and rising in a parallel dance in the east and west. Not only is this stunning to see, but it also means the moon is rising in twilight, and its bright disk will be easier to photograph against the still blue sky. The moon will also appear huge to the easily fooled human mind. When we see the moon next to distant trees or buildings, or in the case of this image, next to giant telescopes, our brain translates it as huge. The thing is, the moon is actually the same size no matter where it is in the sky. And you can check it for yourself by comparing the size of the moon to the size of your pinky nail when you hold your arm out at arm's length. When the moon is on the horizon, it'll be about the size of your pinky. And a few hours later, still the same size when it is higher in the sky. Now, I didn't say exactly when sunset and moonrise will occur because the exact numbers depend on exactly where you are in your time zone and on your landscape. The website timeanddate.com has great tools for looking up this information, as well as a lot of other facts about the sky and time itself. Check it out and make your plans to go out and watch the horizon. Now, if you want to try your hand at taking a spectacular moonrise photo, you should probably actually go out tonight and note where the moon rises and figure out where you need to be to get the alignment you want. Mark the spot and return there with a camera tomorrow. You'll want to use your best telephoto or zoom lens to make the moon as big as possible against a distant object. Tonight's moonrise will be about 45 minutes earlier than tomorrow's, but again, use something like timeanddate.com to get the exact times for your location. If you do get a shot, please share it with us by tagging Daily Space. We'll share the best photos during next week's What's Up segment.
Tomorrow, we'll be back with more science, including new research hinting at how black holes may form from dark matter. For now, though, this has been the Daily Space. You can find more information on all our stories at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.
We'll see you tomorrow. Bye-bye, everyone.
Bye.